All right, everybody, so let's try some more. What happens when we start to compare fractions? Now, there are two things that you can do when you're comparing fractions, and the first one is pretty easy. You can draw models. This one is not the one that I recommend because while it does help you see fractional pieces, you have to make certain that whatever diagram or model you draw to represent one is the exact same size and the exact same shape for the other one. Now, it's usually hard for third graders to draw two circles that are exactly the same size, or two rectangles, or two numbers that are exactly the same size. But for this particular worksheet, let's go ahead and follow the directions. We are going to compare two fractions by shading in a model. 1/3. 3 means there's 3 pieces. 1 means I'm talking about one of them, so I'm going to shade in one of these pieces. 1/4 means that there are 4 pieces, and I'm talking about one of them, so I'm going to shade in one piece. Now, if I do this, it's really easy for me to see that this circle is more shaded in than this circle, which means 1/3 has to be bigger or greater than 1/4. But how can I see that using the math? So we talked about a shortcut that's called the butterfly. Now you've got to know your multiplication to be good with this one. So from bottom to top, we're going to butterfly diagonal numbers and multiply up. 3 times 1 is 3. Here, 4 times 1 is 4. And we have to multiply going up. Whichever fraction has the largest number is the largest fraction. So if I use these numbers, 4 is greater than 3, so this fraction, 1/3, is greater than this fraction, 1/4. Let's go down. 1/2, I'm talking about one of these pieces. 2/3, I'm talking about 2 of these pieces. Now it's easy for me to see that this circle is more shaded in than this circle. So I kind of automatically know using these models that this fraction is greater. But if I multiply 2 times 2, I get 4. If I multiply 3 times 1, I get 3. Since 4 is greater than 3, this fraction, 2/3, is greater than this fraction, 1/2. Sometimes people get tricky. What if I shade in 7 of these 8 pieces? Now you guys can tell that's almost the whole thing. And here I'm going to shade in 9 of the 10 pieces, but I'm going to try and mess with you, and I'm going to leave 1 unshaded that's on the opposite side. Now, it's kind of hard to tell because it looks like this whole thing is mostly shaded and this whole thing is mostly shaded, so sometimes our eyes get tricked. That's when multiplication comes in handy. I'm going to multiply up. 8 times 9 is 72. That might have been a tough one. 10 times 7, well, that's easy because 10 times any number is just that number with the 0. 70 on this side, 72 on this side. 9/10 is greater than 7/8. So what if I try this one? I think I'm gonna shade in 3 of the 4 sections. I think this time I'm going to shade in 6 of the 8. 1, 2, 3, 4, 5, 6, 7, 8 sections. Looks like I need to leave 2 not shaded in. There's 1, 2. There's a 3rd one, a 4th one, a 5th one, and a 6th one. 6 8s are shaded. Now this is just ridiculous. What do? I can't really tell which one is more or less shaded in because here I've got unshaded pieces that aren't together. So I'm going to use my multiplication. 4 times 6 is 24. 8 times 3 is 24. Well, look at that. 24 and 24 are the same or equal. So 3/4 is equal to 6/8. When you can't tell by shading in models, always go back to your multiplication, because on the next level, we're not going to have models to compare.